Okay. So, balikan lang natin yung ating first topic for your reference din. Okay. So, yung unang module natin is about statistics of repeated measurement. Actually, this topic is a review from your statistics during your senior high probably or your analytical chemistry one. So, most probably lahat kayo ay familiar naman na din dito sa topic na to. So let's just look back para lang ma-refresh tayo. Okay, so first let's define what is statistics. So all measurements contain experimental error, so it is never impossible to be completely certain of a result. Okay, so let's have an example na question. Is my red blood cell count today higher than usual? If today's count is twice as high as usual, it is probably truly higher than normal. But what if the high count is not excessively above normal counts? Okay, so in statistics, we do not easily say that a certain number is different from the other. So, yun yung gamit ni statistics. Also, because there are some experimental error na nag-o-occur, possible na yung ating mga results ay hindi certain or hindi siya completely true. Okay? So, let's have an example nga na if yung red blood cell count of the day is higher than the usual. So, on normal days daw, meron tayong ganitong results. 5.1, 5.3, 4.8, 5.4, 5.2 times 10 raised to 6 cells per microliter, which have the average of 5.16 times 10 raised to 6 cells per microliter. But on today's count, meron siyang 5.6 times 10 raised to 6 cells per microliter. So the question is, and can be answered by statistics, is that if this result normal, kahit na on an average, meron tayong ganito lang na result. Or is it acceptable or mataas na ba to or not? So basically, that's what statistics do. Okay. Experimental measurements always contain some variability, so no conclusion can be drawn with certainty. Statistics gives us tools to accept conclusions that have a high probability of being correct and to reject conclusions that do not. Okay, so we cannot easily conclude a result since meron nga tayong mga experimental errors na nangyayari in between our experiment or our test. So yung statistics, it gives us the tool whether or not we'll accept the result or not. So, saan ba siya mag-vary? Mag-vary siya, yung result natin, i-compare natin siya with the true value or with the average value. So, with that, if we know the average value of the normal values or we know the true value or the true result, we can now easily conclude or we can reject the conclusions dun sa result na nakuha natin. Okay. We have the Gaussian distribution or what we call the normal distribution then. If an experiment is repeated many great times and if the errors are purely random, then the results tend to cluster symmetrically about the average value. The more times the experiment is repeated, the more closely the results approach an ideal smooth curve called the Gaussian distribution. In general, we cannot make so many measurements in a lab experiment. You are more likely to repeat an experiment 3 to 5 times than 2,000 times. However, from the small set of results, we can estimate parameters that describe the large set. We can make estimates of statistical behavior from the small number of measurements. We say that the variation in experimental data is normally distributed when replicate measurements exhibit the bell-shaped distribution in. It is equally probable that a measurement will be higher or lower than the mean. The probability of observing any value decreases as it increases from the mean increases. Okay, so let's have this example. So this example is a bar graph and a Gaussian curve describing the lifetimes of a hypothetical set of incandescent light bulbs. So the smooth curve has the same mean, standard deviation, and area as the bar graph. Any infinite set of data, however, will differ from the bell-shaped curve. The more measurements we make, the closer the results will come to the smooth curve. So as you can see here, ito yung uh, graph between the lifetime in hours ng mga bulbs versus the number of bulbs. So as you can see, dun sa tip nung ating curve, naandun yung bulk of the number ng bulbs. Kasi ito nasa gitna yung ating mean. So, ibig sabihin, yung mean natin, as you can see in the graph, mas marami yung number of bulbs na nasa mean kasi siya yung average value or the average lifetime in hours nung mga bulbs natin. And as it increases and as it decreases, lumalayo din siya dun sa mean natin mas umuunti. So this is what we call a normally distributed na curve. This is an example of a Gaussian curve or a normal curve. In the hypothetical case, a manufacturer tested in lifetimes of bulbs in 4,768 electric bulbs. The bar graph shows the number of bulbs with a lifetime in each 20-hour interval. Lifetimes approximate a Gaussian distribution because variations in the construction of light bulbs, such as filament thickness and quality of attachments, are random. The smooth curve is the Gaussian distribution that best fits the data. Any infinite set of data will vary somewhat from the Gaussian curve. Light bulb lifetimes and the corresponding Gaussian curve are characterized by two parameters. Okay, so yung example natin kanina ng Gaussian curve, siya yung tinest ng isang manufacturer for the lifetime na meron tayong number of 4,768 electric bulbs. Okay, so meron tayong 20-hour interval. Okay, so yung bulb natin or yung graph natin, it is characterized by the two parameters, which are the mean and which is also called the average of the measured values divided by n. And we also have the standard deviation, and it measures how closely the data are clustered. So we have this formula for the n, or for the mean or the average, which means the summation of data over the number of samples for the mean. And for the standard deviation, we have this, the summation of mean minus the value minus the mean squared at yung summation niya over n minus 1. So that is the standard deviation. A set having a small standard deviation is more than a set with a large standard deviation. Ibig sabihin, yung mga set or yung set of data natin na merong mas mababang standard deviation ay mas maganda as compared to those set with large standard deviation. Ibig sabihin kasi nun, mas close yung data natin sa isa't isa. Okay, for an infinite set of data, the mean is designated by a lower Greek letter mu, or the population mean, and the standard deviation is written in the lower Greek sigma, the population standard deviation. We can never measure the population mean and the population standard deviation, but the values of the mean and standard deviation approach mu and sigma as the number of measurement increases. Okay, so yung kasing mean, yung mean and standard deviation ay galing siya dun sa set of data natin, at yung population mean and population standard deviation natin, yun yung for the infinite set of data. Ibig sabihin, we have an unknown number of n, for example. Okay, so if we have a known number of samples and we have a known we have a known number of samples, we can definitely calculate for the mean and standard deviation, but it also can be the value of the population mean and population standard deviation, since it they can represent each other naman. N-1 is the degree of freedom, and the square for the standard deviation is called the variance. The standard deviation expressed as a percentage of the mean value, 100 times standard deviation over x, is called the relative standard deviation, or the coefficient of variance. So ito yung mga significant formulas natin aside from the mean and standard deviation. For the variance, squared lang siya ng standard deviation, at si relative standard deviation, RSD, or the coefficient of variance, siya lang yung percentage of the mean value. So this would be the formula for that. Okay. So we have the standard deviation over mean times 100 for the RSD, or the relative standard deviation, and for the coefficient of variance. Okay, so we have already answered this during our synchronous class. So to find the mean, the standard deviation, we'll use the formula of the mean, summation of x over n. So we have this answer. So as you can see, yung maliit na number 2 dyan, ibig sabihin hindi siya significant. So since we only have 3 significant figures, we'll only have the answer that is only 3 significant figures. Same with the standard deviation. Okay, we have 30.3 na standard deviation. From also the formula that we had earlier for the standard deviation. Although we can also use other methods of calculating the mean and standard deviation, example using the Excel or using your calculator. But for the sake of knowing the formula or practicing for the formula, we'll use these formulas for our quizzes and our exams. Okay, so also for the coefficient of variation, or the relative standard deviation, so since we already have the standard deviation and the mean, we can just simply divide them times 100, so we have 3.7% RSD, or percent coefficient of variation. So usually in our in experiments, for example in system precision of an instrument, usually the coefficient of variation required before going through the experiment ay not more than 2%. In an experiment naman yun. So in this case naman, hindi naman siya experiment. So acceptable pa rin naman siya. Ito namang results na to ay titignan lang natin how far are our datas sa isa't isa. So it only shows that the relative standard deviation, or the coefficient of variation in this set of data is 3.7% lang. Okay. Another example if each of the four numbers 821, 783, 834, and 855 in the example is divided by 2, how will the mean, standard deviation, and coefficient of variation be affected? Okay, so we have already answered this also. So the mean and the standard deviation will be divided by 2 but the coefficient of variation is unchanged. Since hindi naman nagkaiba-iba din yung pagkakalayo nila sa isa't isa. Okay, so mababago lang yung value natin pero yung relative standard deviation or the coefficient of variation is will still be the same. Okay, so as you can see here, sa set ng data natin na to, actually makikita naman natin, 'di ba, kung alin yung kung magkakalayo ba sila. Pero we're not certain of the number kung gaano sila magkakalayo. So, yun yung dinedefine lang ng relative standard deviation natin. Okay, so ito yung on how we can calculate for the mean, standard deviation, and relative standard deviation for using the Excel. So, for the mean, we have the average, tapos i-click lang natin yung cell ng kung saan natin siya, kung ano yung hinahanap natin na, yung mga datas natin. I'm not sure if I have okay, so for example, we have this data. Yan. Tingnan natin kung ano yung average niya. So, as you can see, we have the average. Tapos, from A1 to A5. Since nandun yung data na hinahanap. Na gusto nating hanapan ng average, standard deviation, and relative standard deviation. For the standard deviation, STDEV. Tapos, yung data ulit natin. And for the relative standard deviation, we have the standard deviation ng itong mga to over mean, which we have already calculated using also the Excel, times 100. So this would be 2.67% standard deviation. Another one is by using your calculator. Ito, alam niyo na rin naman kung paano siya gamitin. Significant figures in mean and standard deviation. We commonly express experimental results in the form the mean plus or minus the standard deviation where n is equal to the data points. It is sensible to write the preceding result as, for example, 823 plus or minus 30 where n is equal to 4, or even 8.2 times plus or minus 0.3 times 10 raised to 2 where n is equal to 4 to indicate that the mean has just two significant figures. The expressions 823 plus or minus 30 and 8.2 plus or minus 0.3 times 10 raised to 2 are not suitable for continued calculations in which the mean and standard deviation are intermediate results. Retain one or more significant digits to avoid introducing round of errors into subsequent work. Okay, so dito lang sinasabi that if we are just looking for the standard, for the final result, dun lang tayo mag-express ng significant figures. If not, kung meron pa tayong calculations na gagamitin, hindi tayo magbabawas or hindi tayo mag-round off ng result natin. Not until we're already on our final answers. Same goes with other computations naman. Alam nyo na yan since first year naman pinapractice na natin yung significant figures. Okay, so just a recap for the significant figures. Significant figures is the minimum number of digits needed to write a given value in scientific notation without loss of precision. So for example, you only have 4 significant figures. You can write either this way or this way, pero kung kailangan natin is 5 significant figures, we can use this one. Okay? Ito 5 significant, itong dalawa ay 4 significant figures. We can also use naman here 1.4270. Ay, mali. 142.70. Pwede rin naman to for the 5 significant figures. Kasi significant na tong 0 dito sa huli, if ever. Okay. So, for the Gaussian curve, para makita natin yung area dun sa curve, we have this formula. Okay, where E is equal to 2.71828 and it is the base of natural logarithm. For an infinite set of data, we approximate mu by the mean or the sigma by the standard deviation. So as we have said earlier, as I've said earlier, that we can only calculate for the mean and the standard deviation since yun ay galing dun sa set of data na meron tayo. But for an infinite set of data, we approximate the population mean and the population standard deviation using those values, using these calculated values. These values then. Okay, so for example, we have this. Okay, so this Gaussian curve in which the population mean is equal to 0 and the population standard deviation is equal to 1. So we have, on the right side, we have an interval of 1 since yun yung ating standard deviation. We have positive 1, positive 2, and positive 3. Also, from to the left, meron tayong 1 standard deviation each, negative 1, negative 2, and negative 3. Okay, a Gaussian curve whose area is unity is called a normal error curve. Gabc sa z is equal to x minus mu over sigma is the distance away from the mean. And it is measured in units of the standard deviation. When z is equal to 2, there are 2 standard deviations away from the mean. Okay, so yung z natin dito, okay, so ito yung para makompute natin siya. Okay, so for example, sinabi na z is equal to 2, instead of 1, 2, 3, yung ating standard deviation magiging 2, 4, 6 siya. Same goes with the values to the left, negative 2, negative 4, negative 6. Yung value natin to the right will always be equal to the value to the left. Yun nga lang, negative yung nasa left. It is useful to express deviations from the mean value in multiples z of the standard deviation. That is, we transform x into z given by this. Okay, so sabi natin kasi, di ba, dun sa curve natin, ito yung standard deviation niya. But it is easier to use z or in multiples para mas mabilis natin siyang ma-determine or mas mabilis natin siyang ma-interpret. So, we use this formula to find for z. Okay, so, we just replace the population mean and standard deviation using the mean and the standard deviation. Okay, ordinate and area of for the normal or Gaussian curve error curve. So, okay, so we have the z here, y, and the area. Okay, so itong area to, let's look at the 4 highlighted values. We have 1, 2, 3, and 4, which are normally used for the normal or the Gaussian error curve. Okay. So, we have this area. So, ito lang yung pinaka-important natin i-take note. Okay, so let's have first example para mas maintindihan ulit natin. A class of 800 students took the chemistry exam. The average score from the said exam is 75 with a standard deviation of 7. What percent of the class has a possible score between 68 to 82, and how many has scores 81 to 61 to 89? 54 to 75 and greater than or equal to 6. Okay. Okay. So, let's draw first yung ating normal curve. Wherein, na-define na natin yung kanyang average score, which is 75. Diba? Sabi yan na yung mean natin. So, ang standard deviation natin is 7. So, yung first standard deviation natin would be 82. Kasi plus 7 lang naman, di ba? The second standard deviation would be 89. And the third standard deviation is 96. Okay, to the left, since we have 7 na standard deviation, so yung negative 1 standard deviation natin is 68. The second standard deviation, negative 2 standard deviation is 61. And the third, negative 3 standard deviation would be 54. Saan galing ulit yung mga number na yan? Dun sa standard deviation na 7 natin. So, what percent of the class has a possible score between 68 and 82? So, sa 68 and 82, we have from the negative 1 standard deviation papunta sa positive 1 standard deviation. Okay? So, kung titignan natin kanina, sa first standard deviation daw, meron tayong 0.34134 na area. So, ibig sabihin, sa Gaussian curve natin, yung first standard deviation has a 34.13% na area dun sa curve to the right. At meron din siyang 34.13% area to the left. Okay? So we have 34.134. Same goes with this. So, times 2 lang. So, this one occupies how much? Yan yung tinatanong. How much? What percent is the probability of getting 68 to 82%? So, since we have 34.134% dun sa first standard deviation natin, pareho siyang nasa 1, isang nasa negative 1 standard deviation, isang positive 1 standard deviation. So, we have 68.268%. So, we have 68.27% probability of getting 68.82%. Okay. How about for the 61 to 89%? So, question naman is 61 to 89%. So, nandun siya sa positive 2 at negative 2 standard deviation. Okay? So, from mean to the positive 2 standard deviation, ang area niya is 0.4743 na area. So, we have 47.73% from the mean to positive 2 standard deviation. Same goes with from the mean to negative 2 standard deviation. Meron din tayong 47.73%. So, in total, meron tayong 6, 95.46% for this area. Okay, so meron tayong 95.46%. Okay. Pero ang tanong is, how many has scored 61 to 89? So, since we already know how the possible, the percent, how many percent is possible to have that score, we can just simply multiply it by 800 students. Kasi yun yung number of students natin na magte-take. So, we'll just multiply that by the percentage, yung 800. And what we got is approximately 764 na students will get the score 61 to 89. Okay. And for the 54 to 76 or to 75, so that would be from negative 3 to the mean. So, same lang din. Hanapin lang natin yung area ng 3 standard deviation. Okay, so, since we have 49.865, so, yun lang yung magiging area from the mean to the negative 3 standard deviation. So, we have 49.865%. Okay, so, multiply mo lang din siya sa n natin, which is 800. So, we'll get I can't remember the value. Pero, imumultiply mo lang din siya sa 800, which is our n. Okay, rin ko lang. For the last question naman na so we have again 75, 82, 89, 96. Okay, so the question is okay, so question is how many are possible na makakuha ng 96 pataas? So, a question is ito. Okay, so from the mean to the positive 3 standard deviation, meron tayong 498,650 na area. So, ito yon. But the question is this one. So, since we all know na from the mean hanggang sa pinakadulo ng curve natin is 50%, what we can do is to subtract 50 or 0.5 dito sa value ng third standard deviation natin. So, we will have the value of 0.5 0.135%. So this value will be the area for from the standard deviation 3 or the third standard deviation going hanggang dun sa to the infinity, or kung saan man siya, kung hanggang saan man yung score natin. Okay, so again, kaya sinubtract lang natin siya sa 0.5 since we know na yung part from the mean to the right side to the right side ay 0.5 yung area niya. Same goes with the left side, 0.5 lang din yung area niya. Okay, since ang hinahanap natin ay 96 to greater than or equal to 96, and 96 is on the third standard deviation, and yung third standard deviation natin ay 0.49865, sinubtract lang natin siya sa 50 para makuha natin yung area nito. So we have 0.135%, and this value can now be multiplied to 800, which is our N. Okay. Another example, suppose the manufacturer of the bulbs offer to replace free of charge any bulb that burns out in less than 600 hours. If she plans to sell 1,000,000 bulbs, how many extra bulbs should she keep available? So ito lang din yung example natin kanina. So we have already the mean na 845.2 hours. We have standard deviation of 94.2. Okay, so paano ba natin siya sasagutin? We need to express the desired interval in multiples of the standard deviation and then find the area of the interval. So we have z na equals to negative 2.6. And then, kinuha lang natin yung area niya under the curve, which is 0.4953. So the entire area from the mean value, again, is 0.5. So, from the negative infinity to negative 2.6, we only have 0.0047 na area na natira. So, out of, basing on the curve, yung nasa left side daw, meron lang tayo na magkakaroon ng less than 600 hours, ay meron lang 0.47%. So, since for example, they'll manufacture 1,000,000 bulbs a year, meron sila dapat extra na 4,700 bulbs para if ever na yung 0.47% ay magbalik sa kanila, meron silang extra 4,700 na bulb para pang replace. Okay. Okay, pwede rin natin siyang gamitan ng spreadsheet or ng Excel para makuha natin yung area under the Gaussian curve. So, we'll just use these formulas. For the mean, alam na natin yan kanina from the standard deviation. So, para makuha yung negative infinity to 900, okay, so norm this, tapos 900, which is our N. The mean, the standard deviation, and true. So, same with negative infinity to 1,000, then ima-minus mo lang siya para makuha mo yung area from 900 to 1,000. Dito siya sa question na to. What fraction of bulbs is expected to have lifetime between 900 to 1,000? So, from negative infinity, kinuha lang natin yung area from negative infinity to 900. Same with negative infinity to 1,000. Then, subtract lang natin siya para makuha natin yung area between the two. So, that would be the area from 900 to 1,000. Sa spreadsheet kasi, ito lang yung possible way na makita natin yung area ng curve natin. From negative infinity to x. or to our value, to a certain value. The standard deviation measures the width of the Gaussian curve. The larger the value of the population standard deviation, the broader the curve. In any Gaussian curve, 68.3% of the area is in the range from -1 to +1. That is, more than two-thirds of the measurements are expected to lie within the standard deviation of the mean. Also, 95.5% of the area lies within the mean ±2, and 99.7% of the area lies within the population mean ±3. Suppose that you use two different techniques to measure sulfur in coal. Method A has a standard deviation of 0.4%, and the method B has a standard deviation of 1.1%. You can expect that approximately two-thirds of measurements from method A will lie within 0.4% of the mean. For method B, two-thirds will lie within 1.1% of the mean. So, ibig sabihin lang, sinasabi lang dito sa statement na to, that usually, the broader the curve, ibig sabihin, mas mataas yung standard deviation, which we don't want. Mas okay para sa atin na mas mababa yung standard deviation. And normally, in a Gaussian curve, from -1 to +1 standard deviation from the mean, we have 68.3%. And sa ±2 naman of the mean, we have 95.5%, and ±3, we have 99.7%. So, as you can see, mas marami talaga. Yun nasa mas malapit sa mean. Diba? Kasi nga, yun yung average. Yun yung dun mas nagkukumpol yung data natin. Ibig sabihin. Okay, so ito yung for reference lang natin. For reference lang to, para mas mabilis natin makompute yung area from the curve. Kasi usually naman, ito naman yung ginagamit natin, yung 1, 2, and 3 standard deviations. To measure the mean lifetime of a large number of light bulbs, we could select one at a time and measure its lifetime. Alternatively, we could select, say, 4 at a time, measure the life of each, and compute the average of the 4. We repeat this process of measuring 4 at a time many times and compute a mean and standard deviation that we label sigma 4 because it is based on sets of 4 bulbs. The mean of many sets of 4 bulbs is the same as the population mean. However, the standard deviation of the means of sets of 4 bulbs is smaller than the population standard deviation. The relative sigma 4 we call for the standard deviation of the sets of 4 samples in general. The standard deviation of the mean of sets of n samples is computed in this formula. Okay, so sinasabi lang kasi dito na madalas kasi hindi naman natin pwedeng i-test lahat nung, for example, 800 bulbs or 1 million bulbs. Hindi naman natin pwedeng i-test lahat yun isa-isa for its lifetime, di ba? So we just get a set of sample for a certain batch, for example. And then we'll get the standard deviation, the mean and the standard deviation of each set. And then from there, makikita na natin yung population mean and population standard deviation from the different sets that we have. Okay, so that would be all for the first module. If you have any other questions ulit for this topic, just let me know para ma-address ulit natin siya.